Before we start filling out the notebook, I want to ask you a question. If x squared equals 4, what does that make x equal? Well, hopefully the first thing you think of is 2, because I know 2 squared would be 4, so that would work. But there's actually 2 answers to this question. Can you figure out what other value I could put in for x, where if I squared it, I would get 4? I could also put in a -2, because I know when I square a negative number, I end up back with a positive answer. So both of these would work for this problem. And in fact, we have a special notation to write this kind of answer. When your answer is the same number but positive and negative, you can also write x equals plus or minus 2. And so when you see this symbol, that means positive 2 and negative 2 are the answers. Let's fill out the notebook now. So now we'll learn how to solve quadratic equations by using square roots. If your equation is in the form ax squared plus c equals 0, we can solve by square roots. So that means that this can only be used if there's no middle term. In other words, b is 0. I have an x squared term, I have a constant, but no x's. Here are the steps we're going to follow. Step 1 is to isolate the x squared term. We want to get the x squared by itself. Then you're going to take the square root of both sides. And when we take the square root of both sides, we always have to put a plus or a minus symbol. Just like in that example I showed you, if I have a number squared, that means that it could be the positive version of that number or the negative version of that number to get us to that positive answer. So we can get a plus or minus symbol if we go into Insert and Special Character, and we get this box again, and if you search plus, this one actually has the minus on the top, but it's the right idea, so we'll put that in there. So remember that, because there are going to be 2 solutions. I'll make that a little bit bigger. And then your last step is to simplify the square root if necessary, because we always want them in simplest form. Let's try out this example. So let's run through those steps we just wrote down. Step 1 was to isolate the x squared term. Well, in this case, it's already done. I have x squared by itself and the numbers on the other side. So I can move on to step 2, take the square root of both sides. So on the left side, we're going to take the square root, and on the right side, we're going to take the square root. At any time you're taking the square root on both sides, we want to make sure to put a plus or a minus with the number. So the square root of x squared is just x, because the square root and the squared are inverse operations, so they cancel out. And I now have plus or minus the square root of 288. And then step 3 is to simplify the square root if necessary. So I need to simplify this square root. 288 is not a perfect square, so I'm going to break that down and figure out how I can simplify it. So we can always just try numbers if I'm not sure, because 288 isn't a number I use a lot, but I know it's even. So I can definitely divide it by 2, and if I divide it by 2, I get 144. And hey, I actually know that 144 is a perfect square. I could break that down to 12 and 12. And really, in fact, the fact that you have a perfect square and 1 prime, you could use that to simplify, but if you want to keep going and do the full prime factorization, you can. So 12, I could make 3 and 4, and another 3 and 4. So I have 2's prime, 3's prime, 3's prime, and then my 4's are, of course, 2 times 2. Whoops. Don't need that. 2 times 2. So then I can write this as plus or minus the square root of, and I have 1, 2, 3, 4, 5 2's, and then 1, 2, 3's. So I can make one pair of 2s, one pair of 2s, and a pair of 3s. So that means that I'll have a 2 and a 2 and a 3 coming out. So 2 times 2 is 4, times 3 would be 12. And I'm keeping that 2 on the inside. And that's where that 144 comes in. The square root of 144 is 12, and you still have a 2 on the inside. So that is my answer, plus or minus 12 square roots of 2, which I could write out separately as positive 12 square root of 2 and also negative 12 square roots of 2. But you don't have to split it up. You can just leave it like that. Let's try some more examples. X squared equals 9. X squared is already isolated, so all I have to do is take the square root of both sides. Don't forget your plus or minus, and I get x equals, well, 9's a perfect square, so this one's not too bad, plus or minus 3. So x is both a positive 3 and a negative 3. Next one. So this time I do have a bunch of stuff going on. I do need to isolate my x squared term. So I need to get that by itself. So follow your regular order of operations. If I'm trying to get the x term by itself, first I want to get rid of any extra pieces. So that minus 48 is going to go away. I want to add 48 on both sides. So that cancels out. And negative 48 plus 48 does also cancel out, but I don't want to just leave this side blank, so I would put a 0. Next, I need to get rid of that 3. Now that I have the x squared term by itself, I just want to get x squared. So I would divide both sides by 3, and I get x squared equals 0 divided by 3 is 0. Now I can take the square root of both sides, and I get x equals, now while I do put a plus or minus, the square root of 0 is just 0, and there's no such thing as a negative 0. So in this case, there's only one solution. It's just 0. Next, x squared minus 49 equals 0. I want to isolate my x squared term. So I want to get rid of this minus 49, add it on both sides. So x squared equals 49. Take the square root on both sides. Don't forget your plus or minus. X equals, hey, 49, that's another perfect square. So I can just simplify it to plus or minus 7, which again is positive 7 and negative 7. This one looks a little bit different. Instead of just having one variable squared, a y squared, I have a quantity squared, y plus 3 all squared. And you might be thinking, oh, I'm supposed to multiply out y plus 3 times itself. And if I do that, then I'll have a y squared term and we'll have a y term, I'll have a middle term, which means I wouldn't be able to solve by square roots. So I don't want to do that. Instead, because this whole thing is being squared, I have met that first step of isolating the squared part, and I can take the square root of this entire thing. Still put the plus or minus. So this square root will cancel with the squared, and I'm left with y plus 3 equals, and then over here I have another perfect square, so it's just plus or minus 3. And now this is where it's going to be a little bit different, because now I still have to solve for y. I'm not done. And I would say, okay, let's subtract 3 on both sides, but how do I do plus or minus 3 minus 3? Because this is really two different numbers. Well, because I'm not done, I'm going to split this into two separate problems. I have y plus 3 equals positive 3, and also y plus 3 equals a negative 3. And then I'm going to solve both of those. So I will still end up subtracting 3 on both sets of equations. This one is going to equal 0, where this one is going to be a negative 6. So my answers for this one are 0 and negative 6. How about this one? The same setup as the last one. I have this whole quantity squared, but I still have the squared part isolated, so I can start by taking the square root of both sides. And I want to take the square root of negative 36 here, so what's that going to be? Hopefully you remembered we can't take the square root of a negative number because no number squared can be negative. So as soon as I see that I'm taking the square root of the negative number, this is going to be no real solution because I can't take the square root of a negative. You can also write undefined. Last one. I want to isolate the squared part. This time, not only do I have this quantity squared, but this 5 is on the outside. So I can't take the square root yet because that 5 isn't part of the thing being squared. So I have to get rid of the 5 first. So how would I get rid of that 5? I would divide because this is 5 times this whole thing. So to get rid of it, we divide by 5 to cancel the 5's, and I now have x minus 3 squared equals 10. Now I can take the square root that it's just something squared, square root of both sides. Don't forget your plus or minus. And this becomes x minus 3 equals plus or minus the square root of 10. So 10 is not a perfect square. I want to see if I can simplify that at all. What can I break down 10 to? Well, the only things that multiply to 10, besides 1 and 10, are 2 and 5. And 2 and 5 are both prime, and that means there's no pairs in 10. There are no perfect squares in 10. So this is not going to simplify any further. And then my last step is I want to solve for x. So just like the problem previously, I'm going to split this up into two separate things. Either x minus 3 equals the square root of 10, or we have x minus 3 equals negative the square root of 10. So I add 3 on both sides. This cancels and this cancels. Now what do I do with this, the square root of 10 plus 3? Well, I'm not able to combine those together. It's not, they're not like terms. One's in a radical, one's in a square root, and one is not. So I can't actually combine them together. So I'm just going to write that it's 3 plus the square root of 10. Typically, if we have a radical or a square root, we put that at the back. So I would say it's 3 plus the square root of 10, and over here, I have a positive 3 minus the square root of 10, so I would write that as 3 minus the square root of 10. And that's it.